So you are this, not a straight line. Are you getting my point?
Yes, sir.
Not it's between the, okay, this is one is the 0 and this one is the 1. Between 0 or 1, but in much flexible fashion. In this situation, so sometimes it will, it can be adjusted according to the expert, but once you will substitute the value here as exponentially grows. If, for example, see, my children, if you divide 1 over 2, answer is 0.55. If this number will be increased, answer will, what will happen? Decrease.
Yes.
So this line then becomes straight line, decrease. This is known as, basically here, in this situation, very beautiful concept. Not a straight line. We studied the linear classification, straight line. This is the logistic classification. Concept of the logistic following this formula. And I told you a little bit flexibility. So, system adopting the behavior, and this is known as the logistic
classification.
Yeah, this one, my children. This
Yes, sir.
logistic. And in the once you are making an algorithm, you are using some kind of a iteration for determining the weight parameter. And this weight parameter, t times iterations, starting from 0. So with the usage of alpha, some kind of a step size, I will explain for convergence purpose. Once the system becomes stable or almost near to the exact value, so in both the cases, you will apply stochastic gradient descent approach. You may have a question, sir, what will happen in this situation in the binary classification if, at this point, no change? You will have some kind of a system, for example, 1 plus x weight parameter. So if you are taking the partial derivative, then maybe here like 2 or maybe 1. So it will remain 1. But in case of a constant then always 0. So derivative, there is basically no change. At one point the change, step function. In the electrical engineering, it follows the system detailed explanation of this. So, but in case once we will apply the derivative, again and again in the iteration case, some iteration it will become 0. Once we will find the constant. This light. Remain no change. Now it is in a static condition. Or you may say like this, static condition.
Yes.
Only just step down. So, in both cases, it is applying in the algorithm, movement I made algorithm for predicting the weight parameter, basically. So, hopefully, today we covered about the linear classification and linear regression. And I will appreciate if someone of you willingly present about the hinge loss function. Who will? No? Yes, please. Fahid? Come on, Only in this class, very much serious person who want to pay attention. Come on, no? Busy? Well, kind of a busy person, I am really sorry. I don't want to disturb my brilliant students. Someone else, Ashir, what do you say? Will you try? See here. What is your name? Syam. And Ashir, you can decide. Ashir, you are allowed to. Syam, you may represent. Okay. But try to prepare it wonderfully, I know you are better than me, so.
No, sir.
Yeah, now inshallah. We'll record your lecture. Now, how many students? All?
Yes, sir.
Try to, Fahim, this class is not a boring class, okay? We are enjoying in this class, kind of a fun. This class, if you will not study, then AI will not compromise. This is very complex topic. You should be seated, okay, for understanding the concepts.